Hi everyone, this is Aaron Ruck, and today what I'm going to do is I'm going to show you how to verify your program using our Sinutrain software. Alright, so the first thing we're going to do is we have programmed this part. So everything on here we've gone through and written all of the G code, the Fanuc G code for this part. So once that's been completed, we need to verify that it is correct. So what I'm going to do is I'm going to come down to my Sinutrain, which would be on your desktop once it's loaded. I will open this up. When you first open up this software, you might not have these two templates. If you do not, we will get those loaded on there for you. However, once we get to this point, we have our Tulsa Tech Fryer lathe. Okay, so we will hit the start button, and what this will do is it will activate that machine's simulator. Now this will power up a lot faster than it does on the machine. The first thing we're going to do is, once this has come up, I want to get my program that I have written for that part into the machine. So what I'm going to do is I'm going to come over here to the Program Manager. And if you'll notice, I have 3 sub-windows, and I'm going to put my program in the work pieces. But before I do that, I'm going to create a new folder just for my parts. So I will select New, and I'll just simply come over here and type Fryer Test Programs. And then I will hit OK. And after that, I'm going to hit Cancel because I don't want to create a new program. I already have a program. So I will hit Cancel. And then what I will do is, with this highlighted, I'm going to come down to my USB. Now before I click on my USB, I need to have the program that I'm going to simulate on that USB and plugged into my computer. So I have already done that. I will click on USB, and you'll notice here that this name is kind of long, so it's going to throw up an error saying that it's too long. However, I will come over here and make sure that I can see the copy tab right here, so I will make sure it's highlighted. I will hit copy. I will come back over here to NC, make sure that my folder is still highlighted, and I will hit paste. Now it will give me an error, but it will allow me to change it. Well, it just left off the D and the E, and I'm perfectly fine with that. So I'm just going to hit OK, and you'll notice that it came in just fine. Now there's 2 ways we can do things. You'll hear me hitting the keyboard strokes a lot, but I'm going to try and do as much as I can on the screen. So with this highlighted, I'm going to click Open. Now if you'll notice, I have a G291 that turns on my Fanuc. So I only have 2 things I have to do. I have to build my material for the simulator, and I have to build my 3 tools. Good news is it's not going to take very long at all. So what I'm going to do is I'm actually going to, with the caps lock on, I'm going to type out the word workpiece. Now you also have to put an open and closed parentheses or it will not work. I will hit arrow down, and then I'll arrow back up, and then I will hit the right arrow to arrow over. Now by doing that, it actually registers as a workpiece. So if your workpiece was a pipe, block, corner, whatever it is, you could set it up for that. What we're going to be using is a cylinder, and we are using a 1-inch bar. So it says 1-inch diameter. So that's already in there. If it wasn't, I just type in 1.0 and hit enter. Z0 is the face of my part. That's how I programmed it. So I'll hit enter. I can put whatever length I want to on here. I just put it to be a little bit longer than what is sticking out of the chuck. Now in my program it did say to stick the part out 2 inches. This is a good visual for you when you start running your program, so you can see if you're going to run into your chuck jaws. So I made that 1 inch longer than what it's sticking out. And remember, you want to put it in as a negative. If for some reason I put this in as a positive, it might not work. Okay, so now I've got some red numbers. If it comes up red, you just didn't hit it in there as a negative. So I'll hit negative 3.0, negative 2.0. All right. So that will work correctly. Once I have got this done, I will hit accept. And if you'll notice, it went through and saved all my information. The next thing I'm going to do is I'm going to build my tools. Now we want to be very careful when we build these tools because this is where the simulator gets really picky. So I will go to my Offsets tab, and when the simulator pops up, it's going to have a probe. It's going to say turning tool. I'm not able to get rid of this tool for some reason. However, we're going to edit the tool. So the first thing I'm going to do is I'm going to go to Type, and I'm going to click on the tool. I'm going to change it to a roughing tool. It can be a finishing tool as long as it's a turning tool. I'm going to go roughing tool, and I'm going to click the very first one, okay, position number 3. I will hit OK, and it's not going to be, now the tool name has to match what's in my program, okay. So you'll notice it's going to match, but it's not going to be perfect. I'll point that out here in a second. So I'm going to click in the window. Let's change the name to 101. Now in my program, it's 0101. Now that has to do with how the machine calls up the tool in the turret. However, over here, I'm just going to go tool 101. A little confusing, but that's how the simulator likes it. Now I'm going to come over here to my X length. All I'm going to do is I'm going to move this tool away from the home position. If you leave it at 0, it will alarm out saying that it has over-traveled. So I'm going to go -3 inches, enter, -3 inches, enter. Now this was a CNMG 432, so that's going to be as 32 thousandths and 5/10 radius. That will help out with the simulation. It will give me a very accurate simulation. Okay, the cutter edge is going to be that way. If it was a different edge, I could click that way and you'd see how the cutting edge changes. However, I want it to be to the left because I am moving towards the spindle. Angle is going to be 95 degrees. That helps it put it on the correct angle. 80 is going to be my insert angle. Okay, if it was a D and MG, it would obviously be a 55. Now, this insert length is something you can play with a little bit, and we're going to, and I'll show you why it's important. I usually keep it about between 5 and 3. That way you can see it. If it was 0, you wouldn't see anything. So I'll leave it at 4. Spindle rotation. Now remember, you're looking through the spindle, and that is clockwise. And then I'm not going to turn on my coolant because we are just simulating. On the machine, I would simply select both of them. Okay? So if you'll notice, this says location number 1. So my machine sees that tool number 1 is loaded in magazine location 1. Remember that. So I got new tool because I have to make my grooving tool and my threading tool. Let's go back to my program real quick. And I can see that, okay, stick the part out 2 inches. It's 1 inch stock. The Z0, you can do that on the machine. Down here, we see that I have tool 101 as a D and MG. As actually, we did it as a C and MG. That's not going to hurt anything. And then I've got a part off tool, which is 125 thousandths wide, and a threading tool. So we're going to create these next 2 tools right here. Something I want to point out, I said earlier, it has T010. Okay, they don't have to match for some reason. The machine likes it like that. So let's build our next 2 tools, and then we'll get going. So I'm going to make sure I am in a highlighted area. Okay, and it will say new tool. We'll grab our groover. Notice how I want to grab this groover right here because of the cutting edge is on the side, and that's the side we're touching off our tool on the part. I'll select it, and notice how it comes up as plunge cutter. This is tool 2. Enter, and I'll do the same thing, -3 inches, -3 inches. Now, for some reason, the simulator likes for this to have a very small radius. It helps with its simulating. So this area right here is gray, whereas that one was white, meaning I can't put anything there. However, my insert width is 125 thousandths. Hit enter. Now, it's always important that you actually put your micrometers on the insert to make sure that is correct. Also, this is grayed out, and you'll see it has the insert length. We'll just put this at 0.4. We'll just match it. Cutting speed or cutting rotation looks good, and we're not going to use any coolant. But if you'll notice, this does not have a location. This one does. So even though I have physically put the tool into the turret, same thing with it when you're out on the machine, you have loaded the tool onto the turret, but the machine does not know that you have loaded the tool onto the turret. So what we're going to do is simply go load tool. Now make sure you have tool number 2 activated, and then we'll hit load tool. And I want you to always put tool 2 in location 2. Now if it was tool 3, we'd hit location 3, hit enter, and then hit OK. But this is going to be location number 2. We'll hit enter and OK. So now it is loaded in the magazine or in the turret. So we're almost done. Tool number 2, or I'm sorry, tool number 3. We got our threading tool. We're just going with a standard threader. That's the way we want to go. And it's going to be tool 303. Enter. We'll do the same thing. -3 inches. Enter. Now on here, I also put a 1/1000th radius on there. It really does help with the simulation. It helps prevent errors is the reason why I do it. Okay. Now these areas are grayed out. I can't put anything there. Now if you'll notice here, I'm going to show you something. We're going to put this at 0.4, and we're going to notice something in our graphics, and I'll show you why this is critical whenever you're doing certain tools. All right. So last thing, we need to put it into the turret, or let the machine know that we have put it into the turret. We'll simply go load, location number 3, and hit OK. So that's great. All of our tools have been built. I'm going to go into the Program Manager, and then I'm going to open. And then what we want to do is we want to simulate. Now it's going to simulate pretty quickly, and I'm going to show you how to slow that down. So we'll hit simulate, and it's going to actually go through and show you the actual graphics of the part running. This is very helpful because this is the actual tools that you will be using. And this is simulating your code. Now notice how that got dark right there. This is light and that's dark right here on the top of my threads. Okay, so what happened was the cutting edge that goes in the groove was cutting, but so was the side of my insert. And that's not good because now the outside diameter of my threads is incorrect. That's what's good about this simulation, is it will actually show you what's being cut. All right, so let's go back to our offsets, and we're going to change this to 0.7. I'm just making it bigger is all I'm doing. Okay, what that's going to do is my triangle is going to be a lot longer, and that way the groove is going to be able to cut deeper. We'll go to Program Manager, I'll hit open, and we'll simulate again. Again, it's going to go pretty fast. And then I'll show you how to slow it down and see what's going on. Again, notice my G code down here showing what's going on. Grooving. And then this insert's really big now. It's not hitting over here, but you'll notice it does not change colors. Now that we've seen that has fixed that, I want to point out how to run this a little bit slower. So what we're going to do is I have all these tabs over here. I can look at a 3D view. Notice how my chuck jaws are right there. I'll go back to my side view. You've got further views. You can do a face view. You can do a half cut view. You can see if it's doing ID work. You can do 2 windows. I mean, there's a lot of things you can do here. All right, but what we're going to do is we're going to go back to our original view. So I'll hit back. I'll go into my side view. And then I want to go into, I got my details for zooming in, zooming out. And then if you're zoomed in too far, you can click auto zoom. So I'm going to hit back. Now program control is going to help you out a lot. So you can single block your program by activating it. And if you hit back, you'll notice that this says single block. And that's how you can do it. You just sit there and click this single block all the way through your program. So I'll go back to program control. I'll turn that off. But I do want to watch it run slower. So before I hit simulate again, if you'll notice, it's changing the percentage on how fast it's running. So we're going to take it down to about 30. We'll take it down to 30%, and then we can slow it down all the way down to 1%. Okay? So what we'll do is we'll hit back. To re-simulate something, I will simply click simulate and click it again. So if you notice this time, it's going to run a lot slower. And that's good because we can see every little line. Or if we wanted to stop it right in the middle to see what line we're on, we can do that as well. Notice in the groove right here, it does have my 32,000ths radius. So we'll hit play again. And it's going to come in here and start cutting my part. and then it's going to do its final pass, cuts back here, and then I'm going to pause it because I want my grooving tool. I want to go ahead and single block this grooving tool to make sure it's doing what it's supposed to do. So it's going to come over here, it's doing a peck, doing its peck, coming over here, and like I said, this is full control on this, and once it's done, it's going to move away. We'll turn off single block, and we'll go ahead and hit play again. So what I'm going to do is I'm going to slow it down just a little bit more, and then I want to stop it right there. So if you'll notice, before, when this was cutting, right here, you see this is what was actually rubbing on the top of my threads, was that face of that insert, okay? So obviously, if you don't have this threading tool in your machine, you don't have to worry about it. And there's ways that you can custom make the threading tools in there, but for right now I'm using a standard threading tool. So let's let this finish. And then once it gets done, it will come away, and then we'll have our part off tool. Now one thing I do want to point out, let's go ahead and single block this. It's going to come through, it's doing that back edge, and then it comes all the way to X 1/1000ths, okay? Now normally you would move past the center of rotation, which would be -5 10,000ths or 62 thousandths, so whatever you're most comfortable with. However, if you go to X0, this part will fall off. Even in the simulation, it will disappear. So to prevent that, I simply changed my code to stay 1/1000ths off the part. So we'll go ahead and take single block off, and it will simply move back, and our part is done. So you notice that my spindle stopped, and I can see everything in here. Now I can use, like I said, let's go into my details, and I can zoom up. And I usually like to use my arrows for this so you can see all your parts. So if you want to see the top of those threads, I can see everything in here. And if you'll also notice, I can measure certain things in here because all this is to scale. So if I come up to the top of this thread right here, you'll see that I can actually measure. This is 250 thousandths, that's 300, so that's 260, 70, 80, 90. Well, that doesn't really help us that much. And maybe if we were checking our actual part. So let's look at that real fast. Because our part's supposed to be 970 thousandths. And after I show you guys this, that'll be pretty much it. So if you look right here, this gray line is at 1 inch. That's 950. Let's move it over a little bit, and we can actually see where it hits. Oh, I'm sorry, it's supposed to be 990 thousandths. So if you'll notice, this is 950, 960, 70, 80, 90. So 990, you'll see that it's right on line. Those are cool ways that we can check our part in our simulation before we actually run it. So with that said, I'll go to auto zoom, shows my part, and like I said, from here, everything stays set up. So with that said, this is how you can load programs to check your parts in the simulator using Fanuc program. Very helpful. Make sure that you pay close attention, and you can actually use this part. You can take a screenshot of this to kind of see how to format this for your turning using a 2-line can cycle, a grooving using a 2-line can cycle, and then I've got my threading using a 2-line can cycle. Okay, hope you all enjoyed this. Let me know if you have any questions. Again, my name is Aaron Runk with Enjoy.